July 29, 2016. Guys, you're looking at the USGS earthquake map from today. We've had the quake that I warned about in last night's video. It was titled Earthquake Warning Not Watch, and it was because of the filament release that we saw from the sun. We'll look at that again, and there's also a coronal mass ejection that's involved with this particular eruption from the sun. What we have seen was the initial pulse of the filament release. Now, you can have an X flare without a coronal mass ejection. You can have a smaller flare that has a large coronal mass ejection. But when you have a filament release, you're releasing not necessarily the surface of the sun. If you watch it very closely, we'll go to those cameras. But there's a filament that's above the surface of the sun. And when that releases, it's not as dense as the coronal mass ejection. The CME itself was not that strong, and we're going to see the effects of it on the first around 6 a.m. according to one of the tracking models on the first. That will be, I think, this coming Monday morning. But this quake, guys, 7.7, 31 kilometers southwest of Agrahan. This is from Northern Mariana Islands. It's right here. You can see it south of Japan. But it lies on a major fault zone, guys, that even created the Fukushima nightmare right there, if you pull this up. And I saw almost the same thing that day, guys, back when we had the earthquake and the tsunami that created the wave that basically wiped out the Fukushima 1 through 4 Daiichi nuclear plants, and it's leaking radiation all through the planet. And the Pacific Ocean is basically being destroyed on the west coast of America through the Aleutian Islands, and I'm sure there's effects in Hawaii and many other places. But on that day, we had an X flare, and I watched that flare come in about 2:45 in the afternoon as Tokyo and that area was directly facing the sun, which would, especially in a filament release or in the immediate energy created by an X 1.3, I think it was, and we had several strong flares within 3 or 4 days before that. But the flare that got this fault zone came from an X flare. I think it was around 2:45 that afternoon it struck, and we saw in the daytime the tsunami come through Japan. So it's important, like I said in the video last night, I'll stick my neck out on this one. A lot of people downplayed it, but I've seen too many of them, and especially when we looked at the ACE satellite. We'll take a look at that the image, and remember this, guys, that are tracking it, that the high energy protons meaning they add a lot to your reliability on these predictions, because you can see strong pulses on your low energy protons and electrons. But if you see a spike like the one we saw last night on the high energy protons, you can bet that there's going to be problems. But now, again, one thing about this, the depth of the quake was very deep. 212.4 kilometers. It happened this afternoon at 21:85 UTC time. Take about 5 hours back from that for the East Coast, guys. You're looking at 1600 hours, which 4 p.m. this afternoon, East Coast. So it hasn't been that long ago, and we may not be through this entire event, because the coronal mass ejection again is slated to strike the planet on the 1st. And they're saying around 6 a.m. UTC time that morning, which would put it just after midnight or so for the East Coast. Now, it will not be Earth facing. It can still create pressure from anywhere on the fault zone, because if it strikes in one area at night and the fault zone already has pressure on it, you can see it movement. But when you have something moving this fast, then you've got to watch it. And again, we haven't had a quake this large in quite a while. Now, guys, most of the links that I use will be on the front page of our website. Not all, if it's just a random article or something, but things like the satellites that we watch, and especially the ACE data. It says ACE electrons. It's right there. And just below that link, you'll find this. It's called a CME tracker. Now, what they're showing, again, the CME is not as large as many that we've seen, and that's not what I was watching, but we will feel effects from it. But coming in on August the 1st, and they're saying 600 hours UTC time, which would put it just after midnight on the East Coast. They're showing the impact starting. It goes for about 12 hours there. But going back to when I did the video last night, this high energy proton burst on the ACE satellite is why I did the earthquake warning. That's very high. You saw the disruption through the entire magnetic field, the solar wind. You saw that pick up, and that was from the immediate burst. Guys, when light energy travels from a burst, say a flare, or the energy from a higher flare, or the initial burst from even a filament release, that energy can reach Earth in 8.2 minutes. Now, coronal mass ejection, you've got 24 to 48 hours. But all through the spectrum, we saw this impact. Now, we also saw another filament release from the lower left quadrant of the sun. But last night, looking at the drop in the low-energy electrons and proton alpha monitor, very seldom do you see that green line go down. It was almost like a total dropout, and then it tried to pick back up, or a total reversal. That's why the video had to be put up about this, the warning for the 7.7. Now, what the ACE is, if you guys are studying it, is it means NASA Advanced Composition Explorer, and it enables the space weather folks to give us an advance warning of geomagnetic storms. They are a natural hazard like hurricanes and tsunamis, which the National Oceanic and Atmospheric Administration, NOAA, and the Space Weather Prediction Center use to forecast for the public's benefit. Geomagnetic storms impact the electric power grid, aircraft operations, GPS, manned spacecraft, satellite operations, to name some of the most damaging. They can also result in electricity utility blackouts over a wide area. Now, it's located at what's called the L1 libration point between the Earth and the Sun, which is about 1,500,000 kilometers forward of the Earth. It enables ACE to give up to 1 hour advance warning of the arrival of damaging space weather events at Earth. But you have the other instruments like the coronal mass ejection monitor that tracks events that are coming slower. It's because you have that initial flash, you have that event, then you have fast moving filaments, then the coronal mass ejection. And again, that's coming in on August 1st. Notice as we look at the image, in the center is the eruption. It's very faint because we're dealing with the glare of the sun. But in the bottom left quadrant, after that today, we've had another filament release. Just at the center of that light spot, and that will be also Earth effective. Not as strong as the one that we just saw, but we will see energy pulses from that. Now, one other question while we're looking at space satellites: what was the image on the stereo ACE satellite? And everything's marked here: Earth, Mercury, and Venus. On some of the images, you don't see that. And if you look at just the stereo B images, it's much brighter. But that's Venus, and it's on the opposite side of the sun from Earth, but on the side of the sun that the stereo A is. That's why it seems so bright. Coming back to Earth, a couple of things about this. We've got 2 disturbances in the Atlantic. We haven't had much activity this year, but now we're dealing with extreme heat, and that always makes it more dangerous, and we're getting into that time of the year. This first wave is not as organized, and you're looking at the 5-day graphical tropical weather outlook. And you can see that if it gets into warmer water, which they say it may do, then we can see development in the Gulf. The second one, which reminds me of many storms that have come out of the Atlantic, guys, the first one about a week ahead or a few days ahead was a weaker storm, and then we have something like Katrina come in, then the next year Ivan. So we've got to watch this. It's a 50% chance of formation, and if you look at Atlantic satellite imaging, you can see that it is much better organized. It's got to go through a couple of different phases to get here, but it's that time of the year and we need to pay attention. Another thing, I talked about the Fukushima earthquake as we look at this rainbow loop. This is from Meteosat's East Atlantic radar. The front image, you can see it's disorganized. But right here, this loop is the second system that they're watching. Now, it's slightly disorganized now because it's nighttime there, but as the heating of the day comes around and comes over that hot African desert, you're going to see this thing pick up. I've got a feeling because of the intense heat we're seeing here. Now, something about these Atlantic hurricanes, again, and Fukushima. In 2011, when that happened, we had no more large Atlantic hurricanes come into the Gulf of Mexico and do the damage. If you look at this chart and you go back, you can look all the way down it, but you've got here Ivan, 2004, it devastated Florida, Alabama. Katrina got Louisiana and Mississippi. It was very widespread in 2005. But everything else, Irene, Sandy, Ingrid, and Sandy's the one that hit New York so hard, guys. Remember that? But everything else has recurved up the East Coast since the Earth shifted during that Fukushima earthquake. This is what Sandy looked like on October 25th in 2012, the year after the Fukushima event. Everything shifted. That's amazing. We're going to see if that changes, but the reason that we're seeing the dead zones in the Gulf, we're seeing the increase in the flesh-eating bacteria, and the green tides or red tides, all of that, the hypoxic zones, is because these hurricanes normally flush out the Gulf of Mexico. And when that does not occur, when we're dealing with extreme heat, you're going to have problems like we're seeing now. So these hurricanes are a good thing in many ways because of that flushing effect. Also, since the BP oil spill, there hasn't been any great hurricanes come through there, and there was a lot of talk about the Corexit settling large sections of this oil to the bottom of the Gulf. Also, I know a large amount was buried along the beaches. It was not publicized that much, but there was large amounts of oil collected from the beaches and buried